Are you listening me?
Yes, sir.
Yes, sir.
Okay. So in the previous class we have discussed the different kinds of viscosity such as relative viscosity, specific viscosity, reduced viscosity, intrinsic viscosity. So today we will going to discuss the Mark-Horn equation. So actually the intrinsic viscosity of a polymeric solution we found that it increases with increase in the average molar mass of the polymer. So this dependence can be expressed as equation. This dependence can be expressed as equation, and this equation known is the Mark-Horn equation. So this equation is known as Mark-Horn equation. It is actually explain the dependency of intrinsic viscosity with average molar mass of the polymer. So, the, so I'm writing the point also. The the intrinsic viscosity of a polymer solution is found to be or is found to increase with increase in the average molar mass of the polymer. So this dependency can be expressed as so we can write intrinsic viscosity equals to K into average molar mass. So as I am continuing the number of equation, yesterday we have finished up to 24. Now this is equation number 25. So it is the continuation of our previous discussion. Now in this equation, in this equation, K and A are known as and A are known as Mark-Wing, sorry, Mark-Wing constant, and the equation is Mark-Wing equation. CHE আবার constant, and the equation 25 is sorry, equation. So this is the Mark-Wing equation. Now, on which factor the values of and A depends upon? The values of K and A Rajesh. The value of K and A depend on, there are several factors on which they depends upon. Number one, nature of polymer. Nature of polymer. Number two, it will definitely depend upon the nature of solvent used. Nature of solvent. And number three, it definitely depends upon, sorry, it definitely depends upon temperature. Okay, so on these three factors, the constants of Mark-Wing equation, that is K and A, actually depends upon. They actually depends upon on nature of the polymer, nature of the solvent, and temperature of the solvent. So now in equation 25, remember that, so just a minute. So in equation 25, both the intrinsic viscosity and the proportional constant K are expressed in the same way. In the same way. How? Both has actually same unit. Suppose it may be centimeter cube, cc. It may be suppose deciliter per gram and all that. They have same unit. Actually, I want to say that the molar mass, that the molar mass m carries the unit of mass used. In the concentration term appeared in the quantity intrinsic viscosity. In the concentration term appeared in the quantity intrinsic viscosity. So this is the relation between intrinsic viscosity and the average molar mass. So this is the relation between intrinsic viscosity and the average molar mass. The average molar mass that was referred in equation 25 is the viscosity average and we'll going to calculate that how can you calculate this. We're going to discuss how can we calculate this term. So just a minute. Just a minute. So uh, now we are going to discuss that. So next discussion, the average molar mass. I'm writing the point referred to in equation 25 is the viscosity average. Is the viscosity average. Remember that is always the viscosity average. That is, I am also writing the equation viscosity average. Remember that equation, the relative viscosity equals to 0. This is the viscosity average. Okay. Now, how can we explain this or how can we analyze this? So, this can be analyzed since we know that eta is a limiting value as C2 tends to 0, the concentration effect it contains can be written as so we can write it like that, that the specific viscosity, this is equation 26. As our discussion goes on, this is equation 26. Now for uh, polydisperse system, that is polymeric system which can get dissolved in a particular solvent, system, we also have what we have eta specific equals to summation over I. The summation I runs over the concentration. The summation I runs over the concentration. So we can write, if it is runs over concentration, that is Ci intrinsic viscosity of each component. Intrinsic viscosity of each component. So we can say by using Mark-Hoink equation that Ci, putting the value of that K equals to MA I. So nothing else. We have just put Mark-Hoink equation that intrinsic viscosity equals to K into average molar mass. K into average molar mass. So we can say, as the equation goes on, we can say that C2 equals to summation over I Ci. So we can write, definitely the concentration is equals to the total concentration of the substance present. So we can write that is Ci K Mi by A is the Mark-Hoink equation, and in place of C I can write this. So this is our equation number 27, and this is our equation number 27. Now what we can know that intrinsic viscosity equals to K into MA, and again we can say that M bar A, that is the average viscosity, equals to Ci okay. So here we can say, since our mass per unit volume, the above expression can be written as expression can be written as, so we can say m bar, that is average molar mass, equals to summation over mi into a, or to the power a, by, that is mass average. What is mi? Mi is the mass of the ith category of the molecule. So this is equation 9. I am 29. So what is mi? Mi is the mass of the ith category. Category of polymer having molar mass since we know that আমরা কি জানি যে mi equals to ni by Avogadro number into molar mass. So that is, এটা যদি বসাই, if we put this, then we get what is the volume average, summation over I ni mi 1 plus a, you can write ni mi 1 by a. So this is ultimately the 30th equation of our discussion. In generally,
Sir, how this in 1 plus a?
ওইখানে ভ্যালুটা বসাও mi এর জায়গায় ni by mi into mi. So mi has a power 1, there mi is a power a, so total a আর কি ব্যাপারটা ওরকম একটা টার্ম আসবে তো. So what we can write, isn't it? Hello?
Hello sir, আমি লেফট হয়ে গেছিলাম, আবার একটু বলবেন?
Yes. There is a mi, that is in small mi equals to ni by na into capital Mi, that is the molar mass of the ith component. Now if you put mi small mi value there. So একটা term তে mi to the power 1 and another is mi to the power a. So total mi equals to mi to the power 1 plus a.
হ্যাঁ স্যার বুঝতে পেরেছি।
Yes, just a minute. So this is equation of what I'm saying, that I'm saying that in generally number average has highest molar mass, then volume average, then mass average. And for a equals to 1, that is the if the constant is 1 and the value of a equals to 1, that is mv equals to m m. So for most polymerase system, the value of A lies from 0.5 to 1. For most polymer system, the value A lies in the range lies in the range 0.5 to 1.0. So this is all about the relation of intrinsic viscosity. This is all about the relation of intrinsic viscosity with molar mass, average molar mass of the polymeric solution. So it actually gives you the idea that, as we know, that if the intrinsic velocity increases, sorry, if the molar mass increases, the intrinsic viscosity also increases, and this can be deduced by proving this relation. So, so this is the discussion. Just look at that once. If you have any difficulty, then you can ask me. If you have any difficulty, then you can ask me. Do you have any difficulty regarding the discussion? Anyone? Divanki, you asked me for a class discussion. Can you please say me the date?
ওকে স্যার।
Can you please say me the date?
স্যার 4 তারিখ।
Class discussion or the video link? Which
স্যার
one?
নোটস।
No,
নো
okay,
স্যার
okay,
স্যার।
okay, okay. So I'll give it to you. So just to stay for a minute. একটু দাঁড়াও, রোল কলটা করে নি। So অপূর্ব,
Yes, sir.
আইডি,
ইয়েস স্যার।
রাজেশ,
Yes, sir.
তন্ময়, বিজয়, শানুকি,
ইয়েস স্যার।
জাহির, অম্লান,
Yes, sir.
দীপজ্যোতি,
Yes, sir.
হরিপদ, দীপ্তনু,
দীপ্তনা আছে স্যার।
আমি দেখেছি সরি, মাম্পি,
Present, sir.
বিপ্লব,
Present, sir.
বিপ্লব after a long time,
Yes, sir.
উদয় ভানু, নন্দিতা,
Yes, sir.
ওকে, সাগরিকা,
Yes, sir.
কৌশিক, সঞ্জয়, সুমেন,
Yes, sir.
রাজ, দীপাঙ্কিত আছে, অঙ্কুর,
ইয়েস স্যার।
Yes,
বনজ,
sir. আমারটা
দিয়েছি।
Sir.
ওকে, তো শুনেছই তো পরীক্ষা।
আর উদয়
উদয় দিয়েছি, দেখেছি আমি ছিলে। পরীক্ষা তো জানোই সেই হবে, মিড টার্ম। সো বি প্রিপেয়ার্ড, গেট প্রিপেয়ার্ড ফর দ্য এক্সাম।
কবে থেকে স্যার?
নভেম্বর, মেবি লাস্ট উইক, বাট এক্সাম ইজ ইন নভেম্বর, সোজা কথা।
ওকে
স্যার কিছু সাজেশন দিন।
Sir, offline.
এখনো দেয়ার ইজ নো অফিসিয়াল নোটিফিকেশন, তো মেবি অর মে নট বি। তবে মনে হয় অনলাইনই হবে, মনে হয়, আই ডোন্ট শিওর, আই এম নট শিওর, কিন্তু মনে হয় অনলাইনই হবে।
স্যার কিছু সাজেশন দিন।
হুম, যা বলাচ্ছি সবই তো সাজেশন রে বাবা।